Hello, 5th grade. Welcome back to the kitchen. Today, I want to show you how to do two experiments that you can do in your kitchen using common household materials. And they're going to pertain to our lesson last week on acids and bases. But before we get into that, I want to do a quick review of what an acid and a base is so that you know what you're doing when you are doing these experiments in your kitchen. So first off, an acid. We defined acid last week as it's a substance that when it's in a solution, so it's in a liquid form, it readily gives up hydrogen ions for chemical reactions, which are really just protons. If you remember, I showed you how that was the case. So it's a solution that it has lots of protons ready to just give to chemical reactions. So they tend to be pretty reactive substances. And if you remember, there's also that pH scale that tells us how acidic something is. So numbers that are less than a 7 on a pH scale are going to be acidic, and the lower they are, the more acidic they are. Likewise, we also learned about bases, which are kind of like the opposite of acids, and they are substances that will give OH, so hydroxide ions, an oxygen and a hydrogen for chemical reactions, and so they're also reactive. And remember, acids and bases kind of cancel each other out, they neutralize each other. And on a pH scale, bases are going to be greater than 7, usually in the range of 7 to 14. And the higher the number is, the more basic that substance is. And remember, pH of 7 is neutral, so water has a pH of 7. It's not acidic or basic. One of the examples of an acid that I gave you last week was vinegar. Most of you probably have some vinegar in your house. This is just your normal white vinegar from the grocery store. And it has a pH of about 2.4, if I'm not mistaken. And so it's pretty acidic. It's not as acidic as, say, the acid in your stomach or like a battery acid or anything like that, but it's still pretty acidic, so we can use it for some fun reactions in your kitchen here. So, if you have the materials, which I'm about to list, feel free to, you can even like pause the video or watch the whole video and then go and do it, however you want to do that. But feel free to perform these little activities in your kitchen as well and follow along with what I'm doing. If you don't have the materials, you can still enjoy watching me do it, though I think it's more fun to actually get some hands-on experience doing some chemistry in your kitchen. So if you have the materials, it'd be great if you could do it. But if you don't worry, you can still enjoy watching the video. So for the first experiment, we're going to be essentially making plastic out of milk. And if that sounds strange, that is kind of strange. It's not really going to be real plastic, but it's going to be something that feels a lot like plastic. So that's going to be pretty cool. And the materials that you're going to need for that experiment are vinegar, which is our acid, and milk. And those are really the only two ingredients. If you want to use food coloring, you can color your milk as well to make it so the plastic is a different color, but that's not necessary. Other materials you'll need is some way of heating up milk. So I have a little pan or a pot here that I can heat it up on the stove, but I think it should also work if you do it in the microwave. And you're also going to want a strainer, because the plastic that we make is going to kind of be in water, and so we're going to want to be able to separate that out from the water by pouring it through the strainer. So I have this in my sink here. Okay, so let me show you how to set this one up, and then while the milk heats, I'm going to show you how to do the other experiment. So, what I'm going to do, and I'm not going to precisely measure things right here because the precise measurements aren't as important, but if you want to have precise measurements, you can take about a cup of milk and heat that up, and then you're going to use 4, I think, teaspoons or tablespoons, one of those, of vinegar in, you're going to mix those together later. But so you're going to want to put about a cup of milk in whatever you're going to use to heat up your milk. So I'm just going to put it here in this pot. And then I'm going to go ahead and set that on my stove back here and turn the stove on. And while that heats up, I'm going to start the other experiment. Now, one note on heating the milk up is you don't need to heat it up to boiling. It just needs to get warm, so it's more reactive. It doesn't have to be bubbling over or anything. In fact, don't do that. Just make it so it's nice and warm. And for these, you might want an adult to help you so that you don't, burn yourself or spill scalding milk all over the place. So make sure you have a parent's permission and supervision while doing this. Okay, for the second experiment, we are going to be dissolving the shell of an egg. And you might remember that I did this in my classroom last year with the 5th grade when they did chemistry. So I have just a normal egg here and a small glass cup. And basically, this is a very simple experiment to set up. You just put the egg in the cup without breaking it, so very gently. And then what you are going to do is you're going to put vinegar in there until you cover the egg. So there's my egg right there. I'm going to pour some vinegar, which remember is an acid, over the egg. And then really you're just going to let that sit for as long as it takes for the egg shell to dissolve. And you'll notice you can't see it in the video right now, but you'll notice right when you pour that vinegar over top of the egg, little bubbles start forming on the eggshell. And that is a good indication that the chemical reaction is taking place and that it is working. So I'm going to edit the video after I take this. I'm going to put the chemical equation right up here on the screen for you. But what's happening is the eggshell is made of a substance called calcium carbonate. So it's a calcium ion, a carbon ion, and a calcium atom, three oxygen atoms, and a carbon atom. So calcium carbonate is calcium, carbon, and oxygen all put together. And it is found in eggshells, obviously. It's found in other things as well, and it reacts with acid. And so a simplified version of the chemical equation would have the calcium carbonate plus hydrogen, and that hydrogen is what is coming from our acid. And in this case, this is acetic acid, but it just matters that we have the hydrogens in there. This would work with other acids as well. And then the products of that reaction, so those are our reactants, calcium carbonate and the hydrogen. And the products are going to be, carbon dioxide and water. And so basically we're just dissolving this shell into simple things like water and carbon dioxide. And when you see the chemical equation up here, you'll be able to see that all of the atoms balance out. And so that's actually what the bubbles of gas on the eggshell are. It's carbon dioxide, the same stuff that we breathe out our mouths when we breathe, starts to form on the eggshell. Now, I've heard that this experiment works with other things as well, such as chicken bones. So if you happen to have chicken bones around and not eggs, I guess still another part of a chicken, you can go ahead and try it with that as well, if you would like, or instead of an egg. Yeah, so then you can just put this somewhere in your house where it's not going to get spilled and just let it sit for perhaps a few days or as long as it takes for the eggshell to dissolve. And you'll notice that the bubbles actually lift the egg up because bubbles float. So the egg will be partly sticking up above the surface of the acid. So you might want to turn it every once in a while to try and get the shell evenly dissolved. So there's not like mostly dissolved shell and then one little part where it's still hard. Now, the reason that when you dissolve the shell, it doesn't just turn into egg white and egg yolk just becoming a big mess, is that there's actually this thin membrane around the inside of the egg, but inside of the shell that doesn't dissolve in the acid, and so that stays there, and that's the soft, squishy part that you'll see later. So, anyways, I'm just going to go ahead and set this aside for now and go check on my milk, which looks like it is nicely warmed up, and so I can go ahead and get the camera and come show you what I'm going to do next. So, here's my milk. I can see that it is steaming, and so it is ready for the next ingredient, which is vinegar. So I'm going to take a little bit of vinegar, and again, you can precisely measure this out. It's going to be 4 teaspoons or tablespoons. I'll correct that, whichever one it is in the notes. And you're going to add some of that to the warm milk. So I'm just going to take my warm milk here very carefully because it is hot, but not boiling, and I'm just going to add some vinegar to it. And something very interesting happens right away. As I stir it, which I have a spoon here to stir, you'll notice it starts to separate out into what are called curds and whey. And you may have heard that in nursery rhymes and such, curds and whey. So you'll see kind of this thick, plasticky looking white stuff forming, and then also stuff that looks more like water forming. So it's like the milk is separating it out into its white part and its liquid part. And what that actually is those are proteins in the milk. So you hear about protein all the time, like, eating protein if you want to build muscles and such. And there are 2 main kinds of protein in milk. There's what is called whey, and there's what's called casein. Now, whey, so you hear the term curds and whey. That's actually what we're separating this out into right now. The curds are the casein, that's the white stuff that kind of clumps together. And the whey, it doesn't turn into white clumpy stuff, it actually kind of stays in liquid form. And actually, those are both the kind of proteins that are in there. Milk is about 80% casein and about 20% whey, more or less. And so basically, we've separated out the proteins from the rest of the solution here. And the way we did that is acid actually can do what's called denature proteins. So proteins are actually very, very big molecules with hundreds of atoms. And when they're not in their normal environment, so milk proteins are designed to be in milk that's not too acidic, but when you add acid into it, it kind of changes the environment it's in, and the proteins kind of denature. They become different and kind of start clumping together. And that's actually what happens to an egg when you cook it. You denature the proteins and they turn white, and it's kind of solid then and not the liquidy egg white anymore. But anyways, what we're going to do, so I can let go of this pot here, to show you down here in the sink, I have a strainer. You're going to go ahead and pour all of the contents of the pot into the strainer, and you'll see that the curds stay behind and all the liquid will go through. And so I'm just going to let that cool down here. But before the video, actually, I did this same experiment. And you're going to end up gathering all of the protein there. And it'll be this kind of weird, squishy, cheese-like stuff. And what you can do with this then is you can make it into whatever shape you want, and then just let it sit out for about 2 days. And it'll actually dry and harden into something that feels like plastic. So you can make a nice little keychain out of it. You could poke a hole in it. You could paint it when you're done. You can make like a little action figure or something. I think it slightly shrinks when it dries because it's losing material. But you take it out of the strainer and you can shape it into whatever you want. You could pat it flat into a little pancake or something, or a coin. And then you just let it sit out and dry. And then you have your fake plastic that you made from milk. So, I hope that you enjoy doing these experiments in your kitchen if you have the right materials. Vinegar is a very, very useful thing because it is an acid, so it reacts with a lot of different stuff. And so maybe we'll do a few more experiments with acid in the next couple weeks, and we'll have some fun with that. And remind me if I don't remember to do this, but I would love to show you the results of my little experiments here with the egg and with the milk plastic. So hopefully in the next lesson you'll be able to see what ended up coming of this, if I ended up getting a squishy egg or if I ended up getting kind of a little plastic, whatever I make out of this. So you feel free to show me pictures of what you get as well if you end up being able to squishify an egg or make toys or something out of milk. I think that'd be really cool. So feel free to let me know, and even if you want to play around with this and experiment, so maybe like try different acids, see if it'll still work with the milk or still work with the egg. There's different ways you can actually experiment around and make it a true scientific experiment, and I'd love to hear about that if you end up doing some of that. So anyways, I hope that you enjoyed this and hope you have a fun application now for your knowledge of acids and bases. Yeah, I think that's all I have for you, so I will see you next time. All right, take care.